Hi students and aspirants, we are going to discuss an important chapter, that is periodic classification of elements. In that chapter, we are going to discuss an important topic, that is periodic trends. What are all the periodic trends that you have been studied so far? First one is atomic radius, second one is ionization enthalpy, third one is electron gain enthalpy or electron affinity, fourth one is electronegativity. So we're going to start with the first periodic trend, that is atomic radius. What is atomic radius? The distance between the nucleus and the valence shell electron. There is an atom of lithium here, okay? Lithium's nucleus and the valence shell electron. How many shells are present in lithium? 2 shells are present in lithium. Nucleus, first shell and second shell, correct? So the distance between the nucleus and the valence shell electron is your atomic radius. So what happens to this atomic radius along the period and down the group? So along the period, atomic radius decreases and down the group, atomic radius increases. So now we can see the reason behind it. Why atomic radius along the period decreases? Two important factors is there. First one is effective nuclear charge and second one is screening and shielding effect. What is effective nuclear charge? Effective nuclear charge is nothing but the power of the nucleus to hold all the electron towards itself, okay? Which means the nucleus is more powerful. So what is screening and shielding effect? Let's suppose all the inner shell electrons will repel the valence shell electron so that the attraction between the nucleus and the valence shell electron is hindered. Okay, so this is screening and shielding effect. So along the period, the atomic radius is getting decreased because of the effective nuclear charge is getting increased. If the nucleus is becoming more powerful in the sense, it will hold all the valence shell electrons tightly, so that what happens, the size will be getting decreased. Down the group, what happens in the sense, more number of shells will be getting increased. For lithium, it's 2 shell. For sodium, it's 3 shell. For potassium, 4 shell. Rubidium, 5 shell. Cesium, 6 shell. So what happened down the group, the number of shells is getting increased. The effective nuclear charge will also get increased, but it is negligible due to screening and shielding effect. There is more shells is there. So what happens in the sense, more inner electrons will repel the valence electron. So that is why atomic radius down the group it is getting increased and along the period it is getting decreased. Now we shall discuss another one more important factor, that is exceptional case. So along the period, do you think regularly it will be getting decreased? No. The exceptional case is following for the elements beryllium, boron, oxygen, nitrogen. Now imagine the electronic configuration of beryllium and nitrogen. For beryllium, it is 1s2 and 2s2. For nitrogen, it is 1s2, 2s2, 2p3. Beryllium, it's completely filled. Nitrogen, it is half filled. Completely filled and half filled means it leads to stability. Stability means nucleus is more powerful, and what happens in the sense, the size will be still more, it will be getting decreased. So the fluctuation will be happening in case of beryllium, boron and nitrogen, oxygen. Down the group, there is no exceptional case.